Hello everyone. Assalamu alaikum. I hope all of you people are doing well. In this video, I will tell you about three very important force members which are being widely used in mechanical engineering, civil engineering, automotive engineering, aerospace industries, shipbuilding, and a lot of different industries use these types of force members in their product manufacturing. Okay, so the first of the member that I would like to tell you about is basically called as the two force member. Okay, two force member. Okay, as the name suggests, it will be basically consisting up of two forces. Okay, so what is a two force member? If an object in equilibrium is subjected to two forces acting at different points and no other forces are coupled, okay, it is called a two force member. Okay, so what does it mean? That okay, any object, if there is any object, here you have a generic shaped body, okay, and if on that object there are two forces being acting, you can see there are two forces acting at this point A and B, and there must not be any other force or any couple movement over there, then that member will be treated as a two force member. Okay, so for equilibrium requires that these two forces must be equal in magnitude and opposite and parallel to the line between the 2 points. What does it mean? It means these two forces must be collinear, they must be having the same magnitude, and their sense must be opposite. Then that type of a member will be treated as a two force member. Okay, so if you look at it, this is a two force member. If you look at it here, this is basically a linear rod or a linear bracket is over here, in which there are two holes, and you can see you can basically put any bolt over there to hold it in its position. Okay, so at those 2 points you basically apply two forces Fa and Fb. Then these two forces must have the same magnitude, but their direction must be opposite, and these forces must be collinear, and there should not be any movement or couple movement on that. So it will be treated as a two force member. Another very common type of bracket used in everyday affairs is this L-shaped bracket. Okay, so you can see there are two holes punched into it, and again in those two holes basically we can apply these two forces with the same knowledge that they must be, have the same magnitude, opposite sense, they must be collinear to each other, and the two forces must be equal. So this L-shaped bracket could also be treated as a two force member. Okay, so now we have a bracket which is basically a half semicircle, this bracket over here, and again in that bracket if there are two forces acting like Fa and Fb, where Fa equals to Fb, they have the same magnitude, opposite sense, they are collinear, and there is no movement on that line of action, so it will be treated as a two force member. So these are some examples of two force members, and if you want we can get more examples out of it. Again, it is very widely used. These two force members are very widely used in, as I told you, a lot of different industries. They are being used, especially when basically, if you see these dumpsters in everyday construction industries, they are being used. When mineral extraction, you will see these dumpers. Then you see excavators. If you look at excavators, mobile cranes, bulldozers, dumping trucks, front end loaders, they are basically all being constructed by combinations of these two force members and three force members. So you can see basically an excavator is here, and you can see this type of a bracket, and you can see it is having two different points A and B. So these 2 points, if you draw a straight line between these 2 points, we will call it as a two force member. Okay, another example, just for the knowledge point of view, a column, a bridge column could be treated as a two force member as it is in compression. It doesn't matter whether they are in tensile or compressive, but the conditions must be the same. A cable used in bridges which is always has to be in tension, is also a two-force member. An L-shaped bracket has already been explained. A dumpster is here. Okay, so these are all different examples of two-force members to understand what really is a two-force members. More examples so that your concept becomes crystal clear. You can see this type of a bracket, and you can see there is a pin connection over here also, and it is being fixed over here. So if these two, it's being riveted here and it's being pinned over here. So you can see at these two holes where there's a hole here, there's a hole here, where there is our rivet. You can draw a straight line between these 2 points, and basically a two-force member will be formed. And again, this picture, if you look at it, there is a hanging lamp on the street, and if you look, it is basically fixed over here on the wall and then being overhang by means of a rod. This member, if you look at it, this member which is basically reinforcing it is a two-force member. Okay, you can treat it as a two-force member. Another example, if you look, cable is here connected at this point to this point. This can also be treated not AB, but from B to this point, this can be treated as a two-force member. So I hope you have understood the concept of two-force members. Okay. Now let's basically jump to another page over here, which is going to be our three-force members. Okay. Three-force members are a little bit more typical to understand. They are also called as 3FM. So I will make it easy for you by the definition. Three-force member, if an object in equilibrium is subjected to three forces acting at different points and no other forces or couple is acting on it, it is called a three-force member. Okay. So the previous one was two-force members. You were having two forces, but here you will going to have not two, but rather you will have three forces. And the same logic will be there. There must not be any force or extra force or couple acting just beside three forces. And so it will be treated as a three-force member. So equilibrium requires that the three forces be coplanar, which means it has to be in a single plane, XY axis or YZ axis, okay, or XY axis, whatever it is, it has to be coplanar. Okay, if it is non-coplanar, it will not be treated as a three-force member. And that coplanar force system, you can have the choice. If it is parallel, still it will be treated as a three-force member. Okay, if it is parallel, all the three forces, it will be treated as a three-force member. And if the three forces are concurrent, so still it will be treated as a three-force member. Okay, so let's explain what do you mean by parallel and concurrent. So let's try to dig into it so that our concept is more clear. So for concurrent systems, the lines of action of the three forces must intersect at a single point. So what does it mean? It means that any concurrent system to be a three-force members, the line of action of the three forces must intersect at a single point. And what about this single point? This point of intersection may be at the point of application of the other forces, or I will add to it, it may not be at the point of application of one of the forces. It can be in space also. And if they are all converging at a single point, it will be treated as a three-force members. Okay, but whatever plane you are talking about, the intersection must be coplanar. Okay, so let's see what really practically from practical examples of three-force members. Now look, you have one compressive force acting over here, then there is another compressive force and a tensile force. Okay, if I basically project this force along the line of its action at this point, okay, and if I project this force from B to the line of action of point O, and if I project this force, if you can see, to this point O, you will see all these forces are converging at point O. So they thus forming a concurrent force system. And remember, when they are basically concurrent at point O, so we can easily treat it as that summation of all the moments at O must be equal to 0. Okay, so this is a very good example. So this is a three-force member. Okay, this is a three-force member. You can treat it as a three-force member. Okay, let's take another example. We told you that it can be a concurrent force system or it can be parallel forces. If you look, you have a beam over here. There is a pin and there is a ruler. Okay, the pin will have only one horizontal direction, so it is meaningless. So we will treat the vertical direction only, and the ruler has one direction, and there is a external force acting at this point. So if you look, all these three forces are parallel to each other. So this also will constitute a three-force member system. Let's go to another example to understand the concept really well. Concurrent forces. Okay, over here, if you look at it, you have basically got a pin. You know, a pin will have two directions, vertical and horizontal. And if you, these two vertical and horizontal direction will also have a resultant. Okay, it will also have a resultant, which is this. This is the resultant of these two forces. This external force is acting at some angle, and this ruler will also have some sort of a point of action from C. It can go up. Okay, so if you look at it, this force can be projected downwards to point C of the ruler, and the ruler is already acting. Its point of action is at C. Okay, and this force is projected to point C, and this resultant, if you look at it, we can easily project this resultant along the point of action to backward point of action to point C. So again, see all these three forces. Okay, one external force and these two, this resultant reaction of the pin and the roller, they could all be converged and concurrent at this point C. So now, even whenever you look a system like this, you will call it a concurrent. It's a concurrent force system, but this beam will be treated as a three-force member. Okay. So if you look at it, we have another example over here. If you look, there are basically two cables and an external force P. So if you look, this three forces are converging at this point. So we can see one tensile force here, one tensile force here, and one downward force P downwards. So again, this will be a three-force member. Another example, so that our concept is crystal clear, is this three-force member. If you look at it, this is the reinforcing bar over here. Okay, and this reinforcing bar is there, and then there is, if you look at it, which will be treated as a starting from this point to this point. Okay, and you can again see this is the weight of this lamp, which is acting downwards, and again it is being fixed by means of a pin over here. You will have two reactions. So if you look at it, you can basically project these forces. Again, if you say, we can easily say that there will be some sort of this force. There will be, we just there will be some sort of force like here. This is the resultant. Okay, okay, and just make it more angular. Okay, this will be our resultant. So you can basically project this force backward. And again, if you look at it, this force can also be projected backwards. Okay, we're just trying to. So this force can also be projected downwards. Just make it more. Okay. Like this. Like this, here you can see, and here you can. I'm just trying to explain it somewhere here. So these forces can all be projected downwards. Say this is the point O. This is the point O. Okay. So if you look, this is system can also be treated as a. This system can also be treated as a three-force member. Okay, you can treat this system as a three-force member. Okay, so this is the resultant of the pin. This is the resultant of the pin. This is the resultant of this reinforcing bar. okay, which is reinforcing the bracket not to bend, and then the weight, which is going to be vertically downwards, we can basically extrapolate it on the backward, and they're all converging to point 2. So this is another example of a three-force member. So I hope you have understood what really is a three-force member. Okay, now let's go to another very typical force member, which is also termed as a zero force member. Now, what is a zero force member? Okay, especially when we come to trusses. Okay, trusses are very important structures in bridges, in basically warehouses, which are basically being on very large area. We use trusses a lot. Okay, so if you look at it, zero force member is sometimes also symbolized as zero FM, zero force member. So members of a truss, what does zero force members are? Members of a truss structure which has no force or load on it. In other words, it does not support any part of the external loading, are called as zero force member. Okay, so there will be no force or load on these types of members. They are termed as, and there will be no external loading on these types of members. Okay, its purpose, again, what is the purpose of zero force member? Its purpose is to provide additional simplicity during the construction phase of the truss structure. So additional stability, they basically, so that the structure is more reliable, is basically one of the purpose of zero force members. But it has also one unique, very unique purpose, and that is it may start to support loads if the applied loading is altered or changes in the future. Okay, sometimes you want to change the design of the bridge, it can basically function. Sometimes there is natural calamities occurring, like an earthquake or a flooding is happening. Then at that time these force members will start to take some load because of those unique and catastrophic loadings, and basically save the bridge. So this is one of the another very important function of a zero force member. Okay. Now the question arises, how to know in a big bridge what is the zero force member? So you can very easily detect by this definition. If you look at it, they say how to identify zero force member. If one of the two members form a truss joint, provided that no external load or support reaction acts at that joint, then both the members will be zero force member. Okay, so what is it? There are going to be two members. If only two members forms a truss joint, okay, so the two members must be meeting at a joint. Okay, that is very important. There must not be any external load or support reaction at that joint. Then both the members will be zero force members. Now if you look at this picture, if you look at this picture, how do I know what is my zero force member? Okay, can you tell me how do I know what is my zero force member? Yes, according to the definition being provided by us, if you look at this joint A, if you look at this joint A, if you look at this joint A, this joint A has basically these two members AB and AF. Okay, there is no external load like P acting at joint A. There is no external, there is no support like pin and roller over here. Okay, acting what is it says. Then this AF and AB members are treated as zero force members. Okay, so sigma fx equal to 0. So if you apply sigma fx equal to 0 at the joint A, okay, so force AB comes out to be 0. Now again at joint A you apply sigma fy, sum all the forces about y-axis, you will be surprised that force AF will also be 0. So this is what a zero force member is. Okay, now I basically ask you a question. Okay, if you have understood it clearly, in this truss there is another very unique specific joint on which you can again say that that joint is also a zero force member, and I want you people to tell me in the comment section that what is that unique joint which is a zero force member. So I would like to thank you all for seeing this video of mine, and I hope that these unique concepts of two force member, three force member, and zero force member is clearly understood, and you will be basically able to, if you understood these points clearly, this will help you in your future endeavors and whatever basically jobs and tasks you're doing related in all these industries that I've told you. It will be helpful for you. So I thank you all guys for watching my video, and I sincerely hope that you people stay well, and I request you to subscribe to my channel, so well I will come up with more challenging videos and explaining you these engineering concepts, which should try to make. I always try to make it as simple as possible. Thanks a lot.